The last thing we're going to cover here in this section is interpreting the derivative, because it's important to understand what we're doing. What does a derivative tell us? And if you recall, in the first example, we had a watermelon that was dropped from the roof of a building, right? And we had a function for the height above the ground in terms of time. T was time, right? And the height was in meters and time was measured in seconds. So when we found the instantaneous velocity, the units were meters per second, right? Those are the units of velocity. And so in this example, it says that suppose y equals f of t tells us how many miles from home we've driven in t hours. Okay, so what does that tell me? That this f of t, is in miles, and the t value is in hours. All right, the input is in hours, and then it gives us, we give it a t value, and it gives us how many miles from home we've driven. Okay, so the first question is just, what are the units of f prime of t? Well, f prime of t is just going to be the instantaneous velocity, and because f is in miles, right? Miles, and t is in hours, right? We're going to get miles per hour. It's the same units as the average rate of change, right? It's because the numerator is the change in miles and the denominator is the change in the number of hours, so miles per hour. Or we can say miles per hour, right? Some people write mph, right? But it's miles per hour. All right, and part B is asking us to interpret f prime of 2 is 65. Okay, so this is the derivative at t equals 2. All right, so this is saying basically that the t is 2 hours. Okay, so we've driven for 2 hours. So after 2 hours, we can say just after 2 hours, 2 hours, our velocity, right? It's our velocity. It's the instantaneous rate of change. F prime is in miles per hour, and it's velocity. So it's the rate of change of distance over time. So we'll just say velocity. We could say instantaneous velocity, but so our velocity is 65 miles per hour. Okay. All right. So that's just telling us at that time that's what our velocity is. All right. So in general, the units of the derivative are the units of y, right? If y is equal to f of x, right? We're assuming y equals f of x. Okay. So the units of y over the units of x, right? It's the same as the units of delta y over the units of delta x, right? So, um, and that's basically it. And that sometimes helps you interpret what the derivative is telling you, if you can figure out what the units are. All right. So, I will stop here and I'll meet you in the next video.